Hey guys, I'm going to try something a little different today. We're going to take a look at Heron's formula. So I don't often, post public videos. Just want to see if this is something you guys find interesting. If it is, maybe we could look at some more puzzles, fun questions, derivations, proofs, etc. So Heron's formula is a way for us to find the area of an oblique triangle. Now it's easy enough if we have a right triangle. It's just 1/2 base times height. That's pretty simple. But Heron, who was an ancient Greek mathematician, he was able to come up with a method to find the area of a triangle that relies only on the lengths of its sides. Doesn't matter what the angles are. It could be an oblique triangle, no right angle present. Pretty neat. So Heron, sometimes he's also referred to as Hero, grew up in Roman Egypt, in Alexandria, around 10 AD he was born. So this is a very long time ago, and was able to derive a beautiful formula for us to find the area of a triangle. Pretty cool. So there's many different ways to prove this or to derive this. I'm going to take a look at a method today of deriving Heron's formula that just uses algebra, basically. Nothing too crazy here. Doesn't use law of cosines or anything trig-based. Just some good old-fashioned algebra. So let's take a look, guys. Suppose we have a triangle that looks like this. So I'm just going to call this A, B, and C. And I'm going to drop a vertical line here, so a perpendicular line that I'll call H. And I'm going to split C up into two parts. This is X and this is Y. So X plus Y would equal C. Now we all know that the area of a triangle is 1/2 base times height. So my base here would be C, and my height I'm going to call H. So we're going to start off with what we know. Area is 1/2 base times height for a triangle. And using some slick algebra, some derivations, we're going to arrive at Heron's formula, which is pretty cool. And I don't know, not to get too sappy, pretty beautiful formula. The square root of S, S minus A, S minus B, S minus C, where S is the semi-perimeter of a triangle. Kind of cool. Let's see where those numbers come from. So let's get started. First, I want to just put a couple notes here. These will come in handy later. There we go. So my first note, well, 2S would just be A plus B plus C. If I double the semi-perimeter, I'm just going to get A plus B plus C. That's pretty clear. 2 times S minus C, let's say S minus A. This is going to be B plus C minus A. 2 times S minus B would be A plus C minus B. And 2 times S minus C would be A plus B minus C. So we're just going to keep those in our back pocket. We're going to use them later. I'm just making a note of them right now. Now, what else could we do? Well, guys, looking at our base of the triangle C, I think we can all see that X plus Y equals C. The part on the left plus the part on the right equals the whole base. So let's get started. Let X plus Y equals C. Fair enough. So if that's the case, then it looks like we have two right triangles here. So this triangle here on the left, I'll use the Pythagorean theorem, we could see that, well, h squared plus x squared equals a squared. So x squared plus h squared equals a squared. Great. And if I look at this triangle here on the right, I can come up with another. Let's say y squared plus h squared equals b squared. Yeah, got two right triangles there. So we could use the Pythagorean theorem on each of those. All right, so let's continue. Now, since y equals, I'm just going to look at y. If y equals c minus x, now it's going to be algebra time. So what we're going to do, we're going to square both sides. I think we could all agree that y does equal c minus x. Now let's square both sides. So if that's the case, then y squared equals c minus x squared. If I FOIL that out, well, I'm going to get c squared minus 2cx plus x squared. Shout outs to algebra. And now I'm going to add an h squared to both sides. You might be wondering why. Well, what's going on? Just hang in there. So I'm going to add h squared to the left-hand side. And on the right, well, do the same thing. So let's say c squared minus 2cx plus x squared. I'm going to add h squared there too. So on the left and the right, I've added an h squared. Now let's see who's paying attention. On the left, guys, y squared plus h squared. What is y squared plus h squared equal to? This guy right here. Yeah, that's equal to b squared. Yeah. So I get b squared equals c squared minus 2cx plus, next question is, what's x squared plus h squared equal to? If you're screaming at the computer a squared, good. So we can say plus a squared. Okay, I mean, we did that. Wonderful. Let's see if that helps at all. So we've got this. Now what I want to do here, I want to solve for x. I want to solve for x. So I won't bore you too much, but if we shuffle some stuff around and solve for x, from this line above, circled in white, well, I'm going to get x equals a squared plus c squared minus b squared over 2c. Cool. So we've written x in terms of a, b, and c. Wonderful. Why are we doing that? Well, just wait and see. We're going to continue. So h squared, one way for us to think of h squared, if I take this line here, h squared is going to be a squared minus x squared. So we're going to start with that next. So since h squared equals a squared minus x squared, well, we got a difference of squares on the right. Let's factor that. That's going to become a plus x, a minus x. And guys, what's x equal to? X is equal to this disgustingness up here. So our next move is I'm going to plug in for x here and here with that formula we have, a squared plus c squared minus b squared over 2c. All right. So I've got a plus x, a squared, c squared minus b squared over 2c. And then a minus x, again, a squared plus c squared minus b squared over 2c. We plug in for those x's. And now what I'd like to do, I'd like to combine both of these terms. These two terms here and these two terms here. So we can see that the least common denominator is going to be 2c. Let's make a little room here. So in order to combine those, I'm going to have to multiply the a, 2c, 2c. Same thing here, 2c over 2c. So now we'll have two terms that we're multiplying. So on the left, I've got a 2c on the bottom. On the right, I have a 2c on the bottom. When we multiply them, you guessed it, we're going to get a 4c squared. Now going across the top, well, on the left, I'm going to have, let's call it 2ac from here, plus a squared plus c squared minus b squared. On the right, along the top, I'm going to have a 2ac minus a squared minus c squared minus a negative becomes a positive b squared. Okay, so we combined, FOILed everything out, combined like terms. This is what we get. Nice. We got a little bit of work ahead of us. I'm going to rewrite this just to make a little bit more space. So we're going to do a couple cool moves next. So let me just write this a little bit neater. It's hard for me. I apologize. My C's and my A's look suspiciously similar. Yeah, God's working on all of us, guys. All right. So now the fun part. If I take a look at the left, this guy here. Well, I've got an a squared, 2ac, c squared. So those first three terms, I mean, that's just a plus b, a plus c to the second. And then I got a minus b squared in the back. So I could factor that. It's a difference of squares. Yeah. We'll do the same thing on the right. I'll use a different color. Let's go green. So here, I'm going to list the b squared first. Now what we have, well, minus a squared minus c squared plus 2ac. That's the same as minus what we got, a minus c to the second. So guys, check it out. On the left and the right, we've got differences of squares. They're funky, but they're differences of squares. I mean, it's a square minus a square and a square minus a square. We can factor these. We can certainly factor these. So let's factor them and continue the excitement. So on the left, one thing we're going to have, well, I got a plus c plus b. And let's just write them in order, a plus c plus b. So let's say a plus b plus c. Then I'm going to have a plus c minus b. Again, difference of squares down here. For the green, well, again, I got a difference of squares. So let's do b plus a minus c. And the other is going to be b. Then I got minus the quantity a minus c. So minus a minus a negative c would become plus c. Okay, a little weird when we have three terms, but it's still just a difference of squares. That's how this would factor. And on the bottom again, yeah, we got 4c to the second. Cool. If you notice so far, guys, we haven't used any trigonometry. There's no sine, cosine, law of sines, law of cosines, double angles. There's nothing fancy here. Just algebra, good old-fashioned algebra. And now let's go refer to the notes that we listed way up at the top. Remember these little notes here? A plus b plus c is 2s. B plus c minus a is 2 times s minus a. Let's come back. A plus b plus c, hey, that's 2s. A plus c minus b, that's 2 times s minus b. A plus b minus c, well, that's 2 times s minus c. Then here, b plus c minus a, that's 2 times s minus a. Let's write them like this. So 2 times 2 times 2 times 2. Up top, I got 16. S. Let's write them in order. I'll go s minus a, s minus b, s minus c. Alphabetical order rocks. On the bottom, I got 4c squared. We could simplify this. 16 over 4, that's 4. I remember that one. So 4s, s minus a, s minus b, s minus c. On the bottom now, I just got a c squared. So guys, the problem is I solved this for h squared. What I'd really like is to solve this for h. So let's do it. H. I'm just going to take the square root of both of these. Let's see what that gives us. The square root of 4 is 2. Then up top, yuck, I've got the square root of s minus a, s minus b, s minus c. So we can see the beginnings of Heron's formula here. On the bottom, the square root of c squared, well, that's just going to be a c. So that's what we get for h. Now, way back at the beginning, we had a triangle. And we said the area of that triangle is going to be 1/2 the base times the height. Our base was c, and our height is h. So just a quick reminder, here's the triangle that we had. It's 1/2 the base, which I'm calling c, times the height, which we're calling h. So I'm going to plug in with this h right here. Let's see what we get. Area is 1/2 c, all right, whatever c is, then times h. Well, for h, I'm going to plug in this. So I get 2 square root of s minus a, s minus b, s minus c. On the bottom, I have a c. So some stuff's going to cancel, guys. 2 over 2 cancels. C over c cancels. What are we left with? Well, I'm left with area equals the square root of s minus a, s minus b, s minus c. We're left with Heron's formula. Pretty cool. The only thing that we really used here is, some difference of squares, factoring techniques, a couple substitutions, and a little bit of algebra. Nothing too crazy. We were able to derive, Heron's formula. So if you found this fun or interesting or fascinating, who knows? Let me know. Drop a comment, like the video. If this is something that people out there enjoy, heck, I can find some other stuff, post some puzzles, math problems, fun theorems. We can explore some more, guys. But hope you're having a great day. I'll talk to you next time. Bye.